Okay. Now this slide I am covering from the book of Han Kemba only for today because I start with the basics of the classification algorithms today. But later part of the thing I'll have another slide which I have generated from multiple books. Okay, already told to you what we have to cover in the syllabus. Now it's already uploaded on your classroom and you can see the syllabus which is there. Now we have to know what is classification, what is predictions, what are the issues regarding classifications, and the algorithms which you have to do in the decision tree inductions, then the lazy learners, then the algorithm for logistic regression, then the algorithm of naive-based classifiers, and there are few algorithms which you have to do in this. And then at the last, we'll discuss the ensemble methods, where you are going to combine one or more algorithms so that you are going to build a strong classifier. Okay. Now, I am using a word strong classifier. Strong classifiers means those classifiers which can predict, which can classify a difficult tuples. Okay. Now, what is the meaning of difficult tuple? The difficult tuple means those tuples or those objects or those data points which are difficult to classify, because there is a very small difference between, say, the points which are in the which are there, and therefore if you in another which are classified in a different way, and you have to find that small difference between those two data points. Okay. Now therefore sometimes you find that a singular algorithm will not give you a very good result. Therefore what we are going to do is that we are going to combine few algorithms to build a strong classifier. Okay. Now we'll discuss in the ensemble methods, and there's few algorithms for them. One of the very important algorithm which you might have heard is an ADA boost. Okay, so which is a boosting method. There is also another algorithm called random forest. Now these algorithms are basically ensemble methods where multiple classifiers are put together. Okay. Now already we have discussed in the very first class what is the difference between classification and predictions. In the classifications, you predict the categorical class labels. Okay, that means those class labels will be either discrete or could be nominal. Okay, and how do you do that? You construct a model. Now, how will you construct a model? Obviously, you will have a training set which is given to you, and the values of that training sets are already given, which are called as the classifying attributes, and we use those we use that model to classify new data. Now there are two things you have to remember. One is the training set, which is the set of data points or data objects which are given to you in order to make a model, and then you are having a new data on which you will apply that model. Okay. Now obviously the new data will not be a part of the training data. If it is, therefore, if there is a separate data which is a part of the training set, and there is separate data which is a part of a classifying data, that is what we call it as the test set. Okay. Therefore, we will have a training set and a test set. On a training set, we create a model, and on a test set, we test the efficiency of that model. Okay. Therefore, those two data will always be separate, and you should not try to merge those together. Now, it is sometimes also possible that you are not having a separate test set. Okay, that means suppose I have 1000 data points, and all those 1000 data points are training set only. Now, the question arises, where will you apply that model? Therefore, in that case, what we do is that we take some data from the training set only and segregate it as a test set. For example, we apply some 80-20 rule, where 80% data is used to create a model and 20% data is used to test that model. That means in order to check the efficiency of the model, I am going to apply say 75, 25 or 80%. Therefore, the data which you use for training must be large enough. Okay, it should be large enough. Otherwise, the model will underfit. Okay, therefore you are going to apply on a large data. For example, at least 75 to 80% of data or even more than that can be applied for training. Okay. Therefore, but if we are given a separate training set and a separate test set, now the things are easier. You apply the whole training data to make the model, and then you try to apply that model on the test set in order to know the efficiency of the accuracy of the classifier. Okay. In the prediction, you know that it is going to model continuous valued functions, and last time also one of you answered that it is going to apply on a continuous valued function, that means it is going to give you exact values. Okay. Whereas classification always gives you a class label. For example, there could be 2 classes, 3 classes, 4 classes, or n classes, and it is going to give the output in the form of class labels. Now, your typical applications, there are not many. Just for example, it's written 4 over there: credit approval, target marketing, medical diagnosis, fraud detection. There could be a lot of them. For example, document classification. There could be the finding target groups which are going to buy some particular items. Therefore, there could be many hundreds of applications are there which can be. For example, you are very much applying on a vehicle classification. You are going to classify in the house distribution, and therefore there are a lot of classification population based on urban, rural, or based on say some income and so on. So on. There are a lot of applications for this. Now, this is what we have discussed right now. You have a 2-step process where you are having a model and you are using that model. Okay. Now, the models can only be made if you have a predefined classes are given. That means it is given, you already have the classes which are given, and you are going to apply that data in order to make a construction, make a model. Now, how we are going to do that? Each sample is assumed to belong to a predefined class. Okay. That means for each and every sample, the predefined class is already given to you. And this set of tuples are known as the training set. Now, you are going to apply that training set into some of the algorithm, which could be some classification rules, which could be decision tree, which could be mathematical formulas like, for example, you apply a name-based classifier, so you apply a k-nearest neighbor classifier, or you apply a logistic relation, also depends on the type of the data you are having. Therefore, what you are going to do, based on the training set, you are going to apply one of the algorithms over there. And once the model is ready, you are going to classify for unknown objects. Okay. Now, once I get the results for those unknown objects, how will you know whether your model is good or not? You estimate the accuracy of the model. Okay. Now, for the unknown data, you cannot know the accuracy. Why? Because the training set, the test set does not contain the classes. Therefore, what we have to do is that the known label of the test sample is compared with the classified result for the model. That means we already have the training set. We are first of all trying to find the accuracy of that model on the known labels. Okay, the known labels means, for example, I have those 1,000 tuples. I will try to find the accuracy on those 1,000 tuples only. And if I find that the accuracy is good, if I find that the accuracy which is coming is acceptable to in the current domain, then you apply on the unknown data. Because if suppose you directly apply on the unknown data, and the say accuracy comes to be say 70%, or it could come to say 60%, then how will you know whether the model is good or not? Therefore, first of all, you apply on the known labels only. And therefore, what this is already I told you, that test set should be kept independent of training set. Otherwise, overfitting will occur. Okay, that means if you are going to apply, if you are putting a test set with the training set, you will overfit the model, which means that that model is going to learn from the test set also. Okay, it is going to learn. Now, our aim is that the model should only learn from training set. But if you are going to combine both these models together, sorry, both these set together, that means you are combining the training set as well as test set. What happens? The model will overfit because it is going to learn from the test set also, which I don't want, because I want to apply into I have to apply the model on the test set. Now, if the accuracy is acceptable, then you use the model to classify data tuples whose class labels are not known. Therefore, initially I am going to find the accuracy on the known labels itself, and after I find that the known label, that the data is fine, I am going to apply on the unknown data. Okay, is it clear? That means first of all you make a model, then you test that model on the known data, and if I find that the accuracy is acceptable, then you apply on the test data. Okay. Even if you do not have the test data, you are going to make a split, take say 80% data for classification, so for training, and 20% data for testing, and then you apply on those. You make a model on 80% data and apply on the 20% data. Okay. But there are other methods also, that instead of directly putting 80-20, we can have a model where we can try to do that is, we will discuss in the next classes, that is called a cross validation. That means we are going to apply we apply a method of cross validation concepts. Okay. Now this is how you are going to make a model. That means you are given some training data, which is now there are only 6 data over here, and based on this data you apply some classification algorithm over here. We are going to apply some classification models, and based on those classification models, you are going to on this model you are going to rank this. That means this is the classification algorithm you are going to apply, and this is the classification model. Okay. Therefore, you are going to apply those models on therefore. Okay. Fine. Now here, when I am if I made a model, and therefore I have an unseen data over here which is not known. For example, the unseen data has a name of Jeff. He is a professor and having a 4 years of service. Then this is the classifying attributes. Whether you can apply. For example, just okay. Now this is the classifying. Therefore, this is the classifying attribute. This one. This is the classifying attribute. That means this is going to make sure that with what type of what is the output. Therefore, this you have to find it out. This you have to find it out. It's no yes. Okay, and therefore here is the unseen data, and based on this this unknown data, it has been classified as yes. Okay, that means if the person is a professor with a 4-year service, the tenured will be yes, and this unknown data because it did not have that field over there. Okay. Now this was the thing, that when I am applying this training data on this the algorithm, this is what it has learned. This is the thing that it has learned, that if rank is equal to professor or year is greater than 6, then tenured is yes. Otherwise, it is no. Okay, that means the person should be a professor, then tenured is yes, or the person is having the year of service as greater than 6, then it is the tenured is yes. Otherwise, if it is less than 6 and not a professor, it is no. Okay, and this is a rule which has been learned by the classification algorithm and are made as a model, and this rule has been applied over here to classify Jeff Professor 4, and you know that Jeff is a professor, therefore it will be tenured. Or if Jeff is not a professor, the service should be more than 6. If it is greater than 6, it is tenured. Otherwise, it is no. Okay. Fine. Now here, if you see, Tom is an assistant professor with a year 2. Okay, then it is no. Melissa is an associate professor, but a year of service as S7. Therefore, in that case, Here it has given it has made this no, and therefore it is just a example that you are using this data to test. Okay. Now this we already have done. This is a part of the supervised learning where all the classification algorithms come in the example of a supervised learning, which means that the training data are always accompanied by labels. And therefore, it means that you are having labels with the classes. Okay, that means labels with the data, and each and every data will have the labels. Okay. And in an unsupervised learning, you find that class labels of the data is unknown, and therefore the last column is missing. And based on that data only, you have to apply the algorithm. That means the class labels of training data is not known. Whereas in a supervised learning, the class labels of the data is known. And therefore it is called supervised learning, and this is called unsupervised learning. There is another set of problems also which is called a semi-supervised learning. Okay, there is also another part which is called a semi-supervised learning, where you are going to combine some unknown data also in and applying and do it into a classification algorithm. Therefore, we'll discuss in the later part that how the semi-supervised learning is applied. Now, in order to apply this algorithm, you have to first clean the data. That means you have to pre-process the data so that you reduce the noise and handle the missing values. Then you apply the feature sections. That means you have to remove all those irrelevant or redundant attributes. Therefore, those attributes which are not required to be applied for classification. And then you have to transform that. For transformation, what you have to do is that you have to either normalize the data. Normalize means you apply some normalization technique so that some data which is suppose to be very say deviated from the say the mean, you are going to normalize it, and then after that you are applying into the model, and then you are trying to find the accuracy where you are trying to find the accuracy of the classifier. Okay, and when you are going to apply the accuracy of the you calculate the classifier accuracy. Similarly, if you are applying a prediction algorithm, you try to find the predict accuracy. Okay. Now, this is one of the issues, that if you are going to select the classification algorithm, what should be the accuracy? Of course, the accuracy should be high. Then, what should be the speed of classification? Now, obviously, the speed will be having two aspects. One we call the training time, and the second is the prediction time or the classification time. That means the time taken to construct a model is the training time, and the time to use the model is called the classification time. Normally, the training time will be very high, whereas classification time will be very low. Okay, because if you are applying the algorithm on say one data, of course it will take a few microseconds. But in order to make a model, it might take lot of time. Maybe it takes hours and hours also, depending on how many attributes are there and what is the size of the attribute and the type of the attribute. For example, you are applying the attribute, you are trying to apply a classification algorithm on for example, in the image data. It might take 24 hours, 48 hours, even more than that, because the time to read those these pictures will be very much high as compared to say a database file. Okay. For example, you are applying on the multimedia data. It takes a lot of time. Therefore, obviously, normally if you are applying on a small data set of say 1 lakh records, it might take a few minutes. But if you apply on a 1000 video on a images, might take a few minutes, or even it can take say 1 hour, 2 hour, 5 hour, depending on your the hardware also, because you will have to have a good amount of RAM, you will have to have some GPU card along with the speed of the CPU, and there are a lot of factors which are there. But the time of construction will always be higher than the time of classification. Then the third one is robustness. Are the algorithms capable to handle noise and missing values? Then the scalability. Will it work on a disk-resident databases? Why? Because sometimes you cannot put the whole of the database in the RAM. Normally this should have been there. But suppose you are having a 1 GB RAM or maybe a 2 GB RAM and the data comes to be say 100 GB or say 50 GB. You cannot put those 50 GB onto a 1 GB or 2 GB or say 16 GB RAM. Now in that case the algorithm should be able to efficiently work on a disk-resident databases. Now there should be swapping where it should take place. The swapping should take place such that the time taken to swap the data from RAM to hard disk should be as low as possible, and the algorithm should be able to apply should be scalable. Okay. And the last one is called the interpretability. That means whether the model is giving you some understanding provided by the model. Okay. Therefore, is the algorithm going to provide you some understanding of the how it is going to work? Okay. Now, the other issues which are there when you are going to evaluate a model. For example, I have two models, M1 and M2. Which is better? I will compare on these parameters: the accuracy, the speed, the robustness, the scalability, and there are few more factors which are there. That whether which of the algorithm is good. Okay, accuracy is obviously the most important parameter, but there could be other parameters also which are very very important. For example, if the accuracy is say model M1 is 5%, say giving a better accuracy, but the time taken is much higher. I will apply another algorithm which is giving a little lower accuracy, but which takes less amount of time. Okay. Now today we'll discuss the algorithm of the today we'll discuss the name-based classifier. Therefore, today I'll not discuss this one. I'll try to discuss this one. But this is going to be done today in the lab. Now, today I'll do the Bayesian classifier. And Bayesian classifier are basically statistical classifiers. Are statistical. Therefore, it applies statistics over there to classify the tuples. Therefore, it's a probabilistic prediction method. That means it predicts the class membership probabilities. Now, here it is a very important concept that it is going to predict the output of a tuple based on the probabilities. Okay. The foundations of this is given by Thomas Bayes, who gave the algorithm of Bayes theorem, and Bayes theorem algorithm is used in the naive-Bayes classifier. Okay. Now we'll discuss the Bayes theorem just now, and Bayes theorem was given long time back in around say 18th century, but that algorithm was applied in the field of Bayesian classification, and Thomas Bayes was a clergyman in a church, and he discovered this. He gave this algorithm the Bayes theorem. And this theorem is quite effective in most of the cases. Now, the performance of a naive-Bayes classifier is comparable to the decision tree classifiers and also some of the neural network classifiers. Okay. Therefore, if a naive-Bayes classifier is giving the accuracy of say 80%, some of the selected neural networks might give you around same accuracy. I do not mean to say that it is similar to all neural networks classifiers are comparable with naive-Bayes, but some of the neural networks might give you similar results. Now it is an incremental algorithm where when you are going to increment the training examples, the probability will change. Okay. For example, I am trying to build a model with say 100 tuples, and I get some probabilities. Then I add 10 more tuples. Now the whole probability has to be recalculated. Okay. Therefore, this is one of the drawbacks. You can say that as and when you are going to increase or decrease the number of tuples, the probability will keep on decreasing and increasing depending on those tuples. Okay, that means you are going to apply the prior knowledge with the observed data. With the prior knowledge is the knowledge which is already known to you, and you are going to apply with the combined observed data. Okay. Now, even when Bayesian methods are computationally intractable, they provide a standard optimal decision making against the other methods. That means that these are computationally difficult because you have to calculate lot of probabilities, maybe hundreds of probabilities you have to calculate. But even in that case also, you can apply naive-Bayes to calculate, to find the and compare with other methods. For example, naive-Bayes is giving an accuracy of say 80%. Now you can see that what all other algorithms are given. Therefore, it is obviously it is a computationally intensive algorithm. That means it is computationally intensive, and therefore it requires good amount of time in order to apply the algorithm. Therefore, it's computationally intractable algorithm. Okay. Now let me try to come with the algorithm. Now let us discuss the Bayesian theorem first. Now here, let us assume that X is a data sample whose class label is not known. Then it means that this is a test data. Okay, this is test data. Why? Because class label is not known. Okay. And how we are going to proceed is that I will have an hypothesis H. Hypothesis H, which means I assume that X belongs to some class C. Okay. Now try to understand this concept very well. That means I have some data X whose class label is not known. And when I want to know the class label of that X, I first of all assume that X belongs to some class C. And with that assumption is H, which is called the hypothesis. Okay. And then what I'm going to do is that I have to determine the probability of H of X. Now this one you have to know that how this is the probability which is going to be calculated. The probability that the hypothesis holds given the observed data sample X. That means I have to calculate P of H of X. That means the probability that this hypothesis H holds given the observed data sample X. And I calculate the P of H of X. Now this P of H of X is not the direct probability, what you have been knowing about, say, flipping a coin or throwing a dice, which are direct probabilities. Therefore, whenever I am going to calculate the P of H of X, I should know that H holds. I assume that H holds. H holds means H belongs to some class C1, and therefore I assume that this X belongs to class C1, and therefore I am calculating the probability of X, the probability of X belonging to class C1. Okay, and therefore I calculate the P of H of X, and then I calculate PH. PH means the prior probability. Now this is a simple probability. This is a simple probability. That means X, that X tuple will say, let us take an example. If I am having a data which contains, say, 4 attributes. Okay, say some computer. If I want to classify whether X is a person who will buy a computer or not, and I have some attributes for this. For example, the age, the income, whether the person is having a good credit rating, whether the person is a student, and there are some of the attributes which on those attributes I want to classify X, and therefore I am going to apply that algorithm to find for X, and therefore for that I have to calculate the P of H. Then I also calculate P of X, that the probability that the sample data is observed in the other training examples. Therefore, I have P of x, that means the probability that sample data is observed. And then I calculate P of x of h. And this probability is called as the posterior probability. That is called the posterior probability. And this means that the probability of observing the sample x given that the hypothesis holds. Okay. Now I have to calculate first P of h of x, then P of h, and P of x, and P of x of h. And based on these four probabilities, I will apply the Bayesian theorem. Okay. Now, how will I do this? It's not that tricky. Simple algorithm, it is a simple one, where you apply this, you find these probabilities, calculate these probabilities. Now, and then after you calculate that, you just apply the algorithm on this formula. And therefore, if you are given a training data x, the posterior probability of the hypothesis P of h, x, which is this one, is calculated. Therefore, here I have to calculate P of h of x, which is this one, which I will discuss to you, that I am going to calculate this P of h of x. And to calculate this P of h of x, I will calculate P of x of h into P of h by P of x. Okay. Therefore, you have to have three probabilities. The first probability is here. The second probability is this one. And the third probability is this one. And you calculate the first, second, third probabilities, and then you calculate P of h of x. Okay. Therefore, this is called the posterior probability. This is called the posterior probability. Therefore, the posterior probability is given by likelihood into prior by evidence. Okay. The likelihood is given by this P of x of h, prior is given by P of h, and evidence is given by P of x. Okay. Therefore, this formula means that you are going to calculate the posterior probability, which is nothing but likelihood multiplied by prior by evidence. Okay. Now, by applying this algorithm, you can predict a particular tuples belonging to one of the particular classes. How will you do that? You will first of all try to find that which is the highest probability among all. So the meaning is that suppose if there are three classes, say C1, C2, C3, you first of all calculate x belonging to C1, calculate x belonging to C2, and x belonging to C3. The highest among those probability which is there. Therefore, let us take an example. I apply the algorithm and to calculate that the probability of x belonging to C1 is say P1. It is say P1. Therefore, what I am going to do, just a minute. What I will be doing, that I will be applying. Say I calculate the probability say P1. I calculate the probability say P1. Then I calculate the probability P2. I calculate the probability P2. Now, what is this P2? P2 is the probability of x belonging to class C2. P1 is the probability of x belonging to class C1. And I also have I have a P3 which is a probability that the tuple x belongs to class C3. And I have only three classes. And I calculate the probability of all these three. The highest among them will predict that class belongs to that, the x belongs to that class. Okay. Therefore, suppose if I have say 5 classes, I have to calculate the probability of x belonging to C1, C2, C3, C4, C5. But in order to calculate x belongs to P1, you have to calculate lot of probabilities. Okay, you have to calculate lot of probability. Otherwise, for calculating P1, you have to calculate the posterior probability, the prior probability, then the evidence, and then you have to calculate that. Okay. Therefore, it is having a significant computation cost if there are a lot of tuples. The tuples, if they are say 10,000, 20,000, or even more than that number of tuples, it will take a good amount of time to calculate all those probabilities. Okay. Now, based on this algorithm, let me try to come with this. Now here, actually what we are trying to do, when I am applying a naive-Bayes when I am applying a Bayes theorem to naive-Bayes classifier, what I have to do is that I have a training set, okay, which is the D is the data set, and for each of those training set, I have the output of that each and every training data. Okay. Now that means I am having a say I'm having a set of say n number of tuples, and therefore those n number of tuples will be that x, which is nothing but the set of all those n number of say tuples, which will be x1 to x2 xn. Okay. Now that means I will be having a vector x which contains x1 to xn number of data items or data points. And suppose I have say n classes, c1, c2, c2 dot dot till cn. I have vector x which contains n number of data points, and I have n classes which are present in for those n data points. Okay. Now our aim is to perform the classification, and in order to do that, I have to derive the maximum posterior probability. That means I have to maximize probability of Ci of x, where Ci is nothing but C1, C2, C3 till Cm. Okay. Now when I put this into the Bayes theorem, if I put into this Bayes theorem, what I get is that if I apply this P of Ci of x, it is nothing but P of x of Ci. Now here h is now replaced by say this value of Ci, therefore P of x of Ci into P of Ci by P of x. Now here, one thing you should remember, P of x is always fixed. P of x is always fixed because you are trying to only do it for once for the whole data set. Now therefore, this value which I am going to have is always be fixed, will always be the fixed value. This will always be a fixed value. This one. This will always be a fixed value. Whereas, wherever h is coming, you have to calculate that. Because that's a hypothesis and that has to be calculated. Therefore, you have to calculate the P of h of x by using P of x of h and P of h. P of x you have to do only one time. Because P of x will be fixed with the number of tuples. As and when you increase the number of tuples, of course P of x will change. But if the number of tuples are same, the P of x will not change. Okay. Therefore, I will be performing P of Ci of x, which is equal to P of x of Ci by P of Ci by P of x. Now, since Px is constant, I have to only maximize the P of x of, therefore this numerator which is there should have to be normalized. Therefore here what I am going to have to do is that I have to only perform this one. I have to only this one I have to maximize only the numerator part, this part, because the denominator is fixed. Therefore this problem is now coming on to the when I am going to only maximize the numerator part. Therefore, the denominator part need not be addressed. Okay. Now, this one I have to do for P of C1 of x, P of C2 of x, P of C3 of x, and how many classes are there. Similarly, if the left hand side, the C of I is replaced by C1, C2, C3, the right hand side also all Ci will be replaced by C1, C2, C3. And therefore, the number of classes you are having will be the dictating factor of how many probabilities you have to calculate. Okay. Now, based on this concept, let me try to give an example over here. Now, let's take this training set where there are 4 inputs which are given. One is called the age, second is income, third is the student, and fourth is credit rating. The last one, this one, is the output. This is the output. This is the output. That means this is we call it the classifying attribute. computer buying is a classifying attribute, and based on these four parameters of these four attributes, you have to decide whether the particular person will buy a computer or not. Now here age is less than 30, between 30 to 40, greater than 40, and therefore there are three over there: less than or equal to 30, 31 to 40, and greater than 40. The income could be high, medium, or low. The student, the person is either a student or not a student, and the credit rating of that particular person could be fair or excellent. Okay, these are the only four uh, attributes which are used for applying the name-based classifier, and that the computer will be whether buy or not. Therefore, you are only having two classes: C1 buys computer yes, C2 buys computer no, and therefore these are the only two classes which you are going to use. Therefore, these are the only two classes which is no. And you are going to find the probabilities based on these 14 tuples, and now you find that there are 14 tuples over there, and based on these 14 tuples, you have to calculate the probability, and if a new tuple is going to come, you have to classify whether it is a yes or a no. Okay. Now, let us try to understand this concept, and I am going to apply using this one to calculate this P of x of Ci into P of Ci. Okay, so that I calculate P of Ci of x. Okay. Now here, what I am going to do, I first of all calculate the probability of yes, and then I also calculate the probability of no. Therefore, this has to be done only once. Why? Because there are 14 tuples, and out of 14, how many of them are yes? It is simple. If you calculate over here, it is 1, 2, 3, 4, 5, 6, 7, 8, 9. You just see this column, the last column. You just see this column, the last column here. And you find that here, they are basically 9, they are 9 yes and 5 no's. Therefore, irrespective of any other attributes, the probability of buying computer is 9 by 14, and the probability of buying computer no is 5 by 14. Therefore, you are just calculate probability of any tuple being probability of buying computer is yes to be 9 by 14, and the probability of buying computer no is 5 by 14. And then you calculate P of x of Ci. Now here, if you see, I have to calculate the P of x of Ci, because in order to calculate P of Ci of x, you require to calculate P of x of Ci, because you have to calculate this one first. This part, you have to calculate this one first. This one first. Then only you can calculate P of Ci of x. Then what I am going to do, I am calculating P of x of Ci for both the classes. Now what I will do, I will have, for age I have, say less than 30, I will have less than 30, then I have equal to 30, sorry, 31 to 40 and greater than 40. Now less than 30 for buys computer, yes, I calculated how 2 by 9. Why? Because here you find that less than 30 buys computer yes is 2. Which are the two? You see this. Which are the tuples which are there? Which are 2? Now you check there this one. The ninth number. The 9th number less than 30 is yes, and the 11th number less than 30 is yes. Okay. Now you just check this one, this one. This one is yes, and even this one is yes. Now these two are yes, but all other are no. All other no means all which are less than 30 are no. That means how many of them are less than 30? It is 1, 2, 3, 4. 4 of the tuples are less than 30. Okay. It is, no, sorry, 5 of them are less than 30. See this one, 1. This one, 2. Then this is the third one. This is the fourth one. And this is the fifth one. This is the fifth one. and there are 5 tuples. Out of 5, 2 are yes and 3 are no. Therefore, what I am going to do, I am going to calculate 2 by 9 for yes and 3 by 5 for no. Why I am saying 3 by 5? Because there are 5 tuples which are no overall. Therefore, this 5 over here, which is coming over this, is coming in the denominator over here. Similarly, this 9 which is there over the denominator is coming in the probability of no. Why? Because there are only 9 tuples which are yes by computer yes, and therefore out of them, how many of them are less than 30? 2 by 9. Now, therefore, there are 5 tuples which are by computer no, and how many of them are less than 30? 3 of them, and therefore you calculate the probability of 2.222 and 0.6. Similarly, now this is the tuple which is unknown. This one is the tuple which is unknown. And if you see over here, the age is less than 30, income is medium, student is yes, and the credit rating is fair. Therefore, I already know the 4 attributes of that X. Less than 30, income is medium, then the student is yes, and the credit rating is fair. And based on that, I am going to calculate. Therefore, I only have to do it for less than 30 only. Therefore, these 2 I have only done because it is only for less than 30. Because here you have find that this is less than 30. Therefore, since this is less than 30, I only doing for less than 30. Then I take the second one. It is medium. Income is medium. Therefore, if income is medium, I try to find that what is the probability of a person whose income is medium and the person will buy a computer. And again go back to this place and try to find where are the medium. Here, these are the ones. This one. Or this one. No, these are all medium. These are all medium. But out of them, you have to only check for less than 30. Out of them, you have to only check for less than 30, which are only 2. There are only 2 which are less than 30 and nothing medium. Therefore, what you are going to do is that you are going to say apply for medium. What is the probability of if person buys a computer having a medium income? It is 4 by 9. And for no, it is 2 by 5. Therefore, you are calculating for this. Similarly, for student, you check that how many students are there who are having a yes. Who are having a student is yes and buys computer yes. Therefore, you have to again go back and check whether the student is yes and buys computer yes, and you check with that, and you find that you calculate this value to be say 6 by 9. That out of say 9, how many of them are yes? You check how many of them are student. 1, 2, 3. You check from here. 1, 2, 3, 4, 5, 6, 7. Therefore, 7 of them are student. And here, if you are, but you have to check only those persons. Sorry, you have to only check for those persons who are yes, buys computer yes, and are student. It is 6 by 9. And similarly, buys computer no and his student is 1 by 5. And you calculate all these probabilities. Okay. How many probabilities calculated? 8. Why? Because there are 4 attributes and 2 classes. The 4 into 2 is 8. Therefore, you calculated this 8 probabilities. You calculate this as 8 probabilities. Now these are, you calculate the 8 probabilities. The 8 probabilities. And then you have already calculated, now you calculate x of Ci. Now for x of Ci, you multiply all those yes. What are the yes over there? Now that is a simple one. You have to apply with this one. Let me see this value. You apply this value. Then you get this value. These are all yes values. And you multiply all those yes values. Similarly, you multiply all those no values. And you will get 0.044 as the yes, probability of x of ci is 0.044, and the probability of no as 0.019. And from there, now you calculate the numerator. Now here you see that what I told you, that you have to calculate the numerator only, p of x of ci into p of ci, because you have to maximize the numerator part of this equation. You already calculate p of x of ci, and you already calculate p of ci. Then what I am going to do is that I multiply this value of 0.44, which is the p of x of ci, with this value 0.645, because this is p of ci, and therefore I multiply this value, this one, this value with this value, and if I do that, I get the value as 0.028. Similarly, I multiply this value of this point. Now I do the other way. I am going to let us do. Okay. Now I am going to say apply, multiply this one. I calculate the value of this one, and I calculate this for this one, and multiply this 0.019 multiplied by 0.0357. I get the value of 0.007. And now I calculate both the probabilities, 0.028 and 0.007. And I find that yes is bigger. 0.028 is bigger than 0.007, and therefore x belongs to class yes. And therefore I can classify this to be a yes. I can classify this to be, say I can classify this to be yes. Yes. Why? Because the probability of 0.028 is bigger than probability of 0.07. Okay. This is how it actually works. Therefore, you are going to find the value of p of x of ci using, by looking in the database and trying to find all those yes classes and no classes. Okay. Now this is the method, and this given from the book of Hankamber. And now there is a small problem, is that you are multiplying all these probabilities. There is also a chance that one of the probability could become zero. Why? Because there is also that no particular data belongs to that particular class. For example, there is for biased computer no, and having a student yes could be zero. Therefore, this value, say if I say this value is 1, if this value is 1 over here, this value could also become 0. If this value becomes 0, what happens? The whole probability, the output will become 0, because you multiply 0 with anything, it becomes 0. But that is not true, because even if one of the things is not present, does not mean the probability is 0. Therefore, you have to avoid the zero probability problems. That means if any of the probabilities become 0, you cannot directly apply this algorithm. You cannot directly calculate the probabilities. For that, what has to be done is that you have to use the Laplace correction. That is called the Laplace correction. And what I am going to do, if I am having any of the probability which becomes 0, I apply a Laplace correction, also called as Laplace Estimator. What I am doing is that, let us take an example. I have a data set contains 1000 tuples, where income low is 0, and income medium is 919, income high is 10. Now, if I have an income of low as 0, I cannot apply the probability directly, because all those which involve low will have a 0. Then what I am going to do is that I am going to apply a Laplace estimator, where I add 1 to this. I add 1 to this. I am going to add 1 to this. And similarly, I add 1 to all. I will also add 1 to this also. I will also add 1 over here. and I will also add plus 1 over here. And how many numbers I added? I added 3 numbers. Therefore, I will add this 1000. I will also add over here with 3. I will add with this 3. Why? Because with 3? Because I have added 111 3 times. And therefore, the probability what I find will be 1 by 1003, 991 by 1003, and 11 by 1003. And therefore, this probability will not be 0 now. It will have a small value, say 0.00 something, but will never be 0. And therefore, if it is going to multiply with the other one, you will end up in getting a probability which will be near to 0 but will never be 0. And therefore, the corrected probability estimates will be near to uncorrected ones, but will never become 0. Because 1 by 0.1003 will give you, say, 0.001, something around 0.001, which is not, and you multiply with, say, other probabilities, you will end up in getting a smaller value, will never get a 0. And this is called the Laplace correction, or also called Laplace estimator. You have to do only in the case any of the probabilities will become 0. Otherwise, if it is not there, there is no need to apply Laplace estimator. Here you find that no probability became 0. All of them are positive real numbers. Therefore, there is no need to apply the Laplace correction. But it is very much possible that you will end up in having a 0 value also. Okay. Now, one of the problems with naive-Bayes classifier is that it assumes conditional class independence. Now, I am using a very important word, which is called the conditional class independence. Now, the meaning of this is conditional class independent. That means we assume that all these classes are all independent of each other, and these attributes are not related to one another. That means all those attributes are not related directly to one another. That means there is no effect of one attribute on another attribute. And therefore, this word naive, what we are going to write over here, naive means a simple. That means the probabilities are calculated by assuming that the Bayesian classifier is a simple naive-Bayes classifier, which assumes that it is a conditional class independence. And therefore, this naive stands for a simple Bayesian classifier, which assumes conditional class independence. Now, a word of caution: you don't apply naive-Bayes classifiers where you know that these attributes are dependent on one another. For example, don't apply on those data sets where you know that if one of the attributes is going to change, it will also change the other attributes. For example, if I apply on a medical diagnosis, if some of the result of a diagnosis comes to be positive, now in that case, the other attributes might also change. For example, suppose if a blood test comes to be positive, in that case, the X-ray of a person might become positive also, because those attributes might be dependent on one another. Now, at that, if you find over there, you don't apply this, because it is going to that this type of relationship is not captured in the naive-Bayes classifier, and therefore don't apply if you know that those attributes are dependent on one another. We'll discuss in the third class the concept of Bayesian belief network, where you can model such type of relationship into a Bayesian belief network. And Bayesian belief networks does not take the conditional class independence into consideration, but will take the conditional class dependency. Therefore, naive-Bayes takes conditional class independence. Bayesian belief network takes conditional dependency into consideration while trying to classify a particular tuples. Okay. Now this you have to. I've already given the basic of this. Now what you have to do is that you have to just go through this slide, and you have to find that what is the and a problem will given to you in the class today, and you have to attempt this question. Anything you want to ask, please? Now, today there is a meeting with the Vice Chancellor to decide for the college opening, and I think the final year, if it is decided positively today, the college might reopen soon. Therefore, we are having a meeting today and decide in the second half that whether the college should reopen for the offline mode. The thrust is on the final year because the university is a little wants to open the for the final year student, at least for the masters student first, and then for the BTech student. Therefore, we hope that if we decide the meeting today, we might end up in opening the college. Now, anything you want to ask?